Okay, so now we're going to talk about inverse matrices. So we've learned to use Gaussian elimination, Gauss-Jordan elimination to find the solutions of systems of linear equations. You can also use the inverse calculation. But before we can use the inverse to find the solution, we have to know how to create the inverse of a matrix. So that's what we're doing in this section. And the whole concept of inverse is if you have a matrix A and you multiply it by its inverse, you get the identity matrix. So it's kind of like A times 1 over A is equal to 1. That's the algebra equivalent. Okay, so we start off with a 2 by 2, which is the easiest to do. So that's our original matrix. So again, you're going to use augmented matrices. The difference here between what we've done previously is that the augmented part is the identity matrix. Then what we're going to do is we're going to make this into this matrix, and what's left over here is the inverse. So we just do the same thing we did before. We do the operations to make this go 1, 0, 0, 1, and then see what we end up with. Okay, so first thing I'm going to do is, first row's good because I have 1 here already. So what I'm going to do is I'm going to take the second row and multiply it. No, I'm going to take the first row and multiply it by -2. So I'll get, if I do this multiplied by -2, I'll get -2, +4, -2, 0. So that's each one of these multiplied by -2. And then I'm going to add it to the second row. I'm going to make sure to include all of the elements, not just from this small case. So what you get is 0, 7, -2, 1. Okay, so the matrix now becomes, the first row stays the same. Second row becomes 0, 7, -2, 1. Now what I'm going to do is I'm going to divide the second row by 7. So I'm going to take every element in the second row and divide by 7. So I get 1, -2/7, 1/7. Okay, and then finally I want to get a 0 here. So what I'm going to do is I'm going to take the second row and multiply by 2, which will then add. So we'll take the second row and multiply by 2. So you get 2 times 0 is 2, 2 times 1 is 1, 2 times -7, 2/7 is -4/7, and 2 times 1/7 is 2/7. Okay, then you add that to the first row, like that. So 0 plus 1 is 1, 2 plus -2 is 0. That was the whole purpose of doing what we did to the second row. You add these two together, you get -4/7 plus 1/7 is going to be 3/7. 7/7 minus 4/7 is 3/7. And I add these two together and I get 2/7. So my final equation, I replace the first row with this, so I get 1, 0, 3/7, 2/7, 0, 1, and then my second row is -2/7, 1/7. So if I say that the matrix A is the original matrix, which was 1, -2, 2, 3, that's A, then A inverse is equal to 3/7, 2/7, -2/7, 1/7. Now I said if you take A and you multiply by A inverse, you should get the identity matrix. So let's just see what happens here. So it's a 2 by 2 multiplied by 2 by 2. You take this times that, so you get 3/7, and then you get -2 times -2. So that's +4, so you get plus 4/7. So this times that plus that times that. That gives you the first entry. This one up here, you take -2 times, let's see, this times that. So now we got to take this times that. So you get 1 times 2/7, so you get 2/7. And -2 times 1/7, so you get -2/7. So this times that's 2/7, this times that's -2/7. Okay, here you take 2 times 3, so that's 6/7. And then you take 3 times -2, which is -6/7. And then to find this one, you take this row versus this column. So you get 2 times 2 is 4, 4/7. 3 times 1 is 3, so you get plus 3/7. And you can see that these two terms add up to 7/7, which is 1. These two add up to 0. These two add up to 0. These two add up to 7/7, which is 1. And you can see that the matrix times its inverse gives you the identity matrix. Okay, 21. So this is a 3 by 3 matrix. So it's 1, 1, 1, 3, 5, 4, 3, 6, 5. So that's the original matrix. To find the inverse, I create an augmented matrix. And I augment it with the corresponding identity matrix, where you have 1s on the diagonal and 0s everywhere else. Okay, so what I'm going to do is I want to get 0 here and 0 there. So the first case, I'm going to take the first row and multiply by -3. Actually, I'm going to do that in both cases. So I get -3, -3, -3, -3, 0, 0. So this is just this whole row. And then I'm going to add it to the second row. So I get 3, 5, 4, 0, 1, 0. Add these elements together. I'll get 0, 2, 1, -3, 1, 0. So that's my new second row. So let's go ahead and do that over here. So the first row stays the same for right now. The second row will now become 0, 2, 1, -3, 1, 0. Okay, now again, use the same multiplier of the first row, which was -3. And I'm going to add that to my third row, which is 3, 6, 5, 0, 0, 1. Add those together. You'll get 0, 3, 2, -3, 0, 1. So just adding these in columns. So my new third row becomes 0, 3, 2, -3, 0, 1. Okay, what do we do now? We want to get a 1 in this position, so and there's more than one option. One thing I could do is I could if I divide by 2, I'm going to get fractions. If I divide by 3, I'm going to get fractions. But I could, take the negative of this row, which would be -3, and if I add -3 to 2, I'll get -1, and then I can just change the sign. or I could divide this by 2. So I'm going to, there's multiple ways that you can approach this. You get the same answer no matter what you do. So I think I'm going to do what I just said. I'm going to take the negative of the third row, and I'm going to add that to the second row. So I add those together, I'll get 0, negative 1, negative 1, 0, 1, negative 1. And then I'm going to change the sign of it. So it becomes 0, 1, 1, 0, 1, negative 1, 1. So what I have is first row stays the same. Second row becomes 0, 1, 1, 0, negative 1, 1. The third row, I'm going to leave the same right now, so we don't try to do too many things at one time. Okay, now, I want to get a 0 here. So if I take the second row, which is this thing right here, and I multiply by negative 3. So take this row, I multiply everything by negative 3, like that. And then I add that to the third row. And the result is 0, 0, negative 1, negative 3, 3, negative 2. So just adding these values together. So then I get 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, negative 1, 1. And then for the third row, I get that, but I can change the sign. So let me go ahead and just change the sign. So if you do that, you get 0, 0, 1, 3, negative 3, 2. Okay, so that'll be the new third row. So you get 0, 0, 1, 3, negative 3, 2. And the reason I did that is so that I didn't have to take one extra step here. Now I've got ones along the diagonal, I've got zeros here. So what I'm going to do next is I want to get a 0 there. To do that, I take the third row and I multiply by negative 1, which means I just change the signs of everything. I add that to the second row. Negative 1. Add those two together, you get 0, 1, 0, negative 3, 2, negative 1. And actually, I'm going to do two things at one time here. The second thing I could do, so I'm going to plug that in for here, but I'm going to go ahead and make that go to 0 too. So I'm going to do the same thing. I'm going to take the third row, 0, 0, multiply it by negative 1, add that to the first row, 1, 1, 1, 1, 0, 0. Add those together, you'll get 1, 1, 0, negative 2, 3, 2. So I'm just adding columns. Okay, now I'm going to replace the first row with that. So I'll get 1, 1, 0, negative 2, 3, 2. The second row is this. So I use that 1, 0, 1, 0, negative 3, 2, negative 1. And the last row is the same because that's just what I want it to be. Like that. And then the last step, I want to make this go to 0. So if I take the second row, multiply by negative 1, So this is this row multiplied by -1. Add that to the first row. I'll get 1, 0, 0, 1, 1, 3. So my final augmented matrix is going to be 1. So I'll replace this for row 1. So I get 1, 0, 0, 1, 1, 3, 0, 1, 0, -3, 2, -1, 0, 0, 1, 3, -3, 2. And so if my original matrix A, which was, which number am I working on? Oh, this is 21. Okay. So my original matrix was 1, 1, 1, 3, 5, 4, 3, 6, 5. Then I'm saying that A inverse is equal to the matrix, this part here, which is going to be 1, 1, 3, -3, 2, -1, 3, -3, 2. So to check to see if I've done this correctly, I can do the matrix multiplication. This is A inverse, so if A times A inverse, let's just try a few things out here. So this, it's going to be a 3 by 3 matrix. So if I take this row times this column, I'll have 1 times 1, and then I'll have 1 times -3, which is -3, and I'll have 1 times +3. So these two cancel out, and you just end up with 1. Okay, the next one, you take this row versus that column. So what I'll have, let's just write it out. You'll get 1 times 1, 1 times 1. You'll have 1 times 2 plus 1 times 2. And then you take this, which is going to be equal to 1 times -3. And so 1 plus 2 is 3, minus 3 is 0. So you get 0. So you can see how it is working out as far as actually being the inverse. Okay, next one. The next one says use the matrix capabilities of the graphing utility to find the inverse of the matrix. So there you have to enter, you have to have a TI 84, 85, and you've got, so what you're going to do is you're going to push, you're going to do the matrix function. So I do second matrix, which is right into the inverse thing. And you'll see names, math, and edit. So you go to edit. So use your cursor to move to edit. And matrix A, to enter the data for matrix A, you just push 1. And you put 3 by 3. So 3 by 3 matrix. And then you enter the data. So you just put the numbers in, push enter. Have 9 numbers to enter. It'll automatically move to the next entry point when you push enter. So you should see a matrix. It's 10, 5, -7, -5, 1, 4, 3, 2, -2. Okay, so that's the matrix. Then you quit. And then all you have to do is you go to second matrix. You'll see that A is 3 by 3. You choose 1. So now you'll see a little matrix A with little matrix symbols, and then you push the x to the -1 power without any second. Just puts a little -1 as an exponent. You push enter. And if you do that to problem number 28, you get the inverse of matrix A is -10, -4, 27, 2, 1, -5, -13, -5, 35. And that's it. So I'm just going to double check, make sure I entered the stuff right. So it's 10, -4, 27, 2, 1, -5, -13. Yeah, okay, so I did that right. Okay, the next problem is 31. So 31, 2, 1, 0, -3/2, 0, -1, 1/2. Okay, so the first thing you should recognize is that it's not a symmetric matrix. It's not 2 by 2 or 3 by 3, it's 2 by 3, and therefore can't take the inverse of a non-square matrix. So I'm just double checking that's true, but I'm 99% sure it's true. So it says, oh, okay, look at the right chapter. 31. Wait a second. Is that 31? Oh, okay. I missed part of the matrix. I thought it was in the previous problem. So that's not true. Okay, so it is a 3 by 3 matrix. But if you got one that wasn't square, then there is no inverse of a non-square matrix. So we learned something. Anyway, this is 31. So again, you can enter these numbers in to your matrix in the calculator. So what you do again is you go to second matrix, go to edit, choose 1, which is matrix A, 3 by 3, enter -0.5, 0.75, 0.25, 1, 0, -1.5, 0, -1, 0.5, okay, then quit, go to second matrix, choose from names, choose 1, push the inverse x to minus 1 power, and you get the inverse of this matrix is going to be -12, -5, -9, -4, -2, -4, -8, -4, -6. Let's double check that. Problem number 31. Okay, so that's good. And what do we got now? Oh, actually, that was the previous section. Ah, rats. Okay. Anyway, there's one for free. 53 says use an inverse matrix to solve it if possible. Okay. So 53, we have two equations. Okay, so what we're going to do is we're going to, the A matrix in this case is 3, 4, 5, 3. So we don't use an augmented matrix. what we do, I'm going to do this by hand, not using the calculator. So you create an augmented matrix with the identity matrix to the right. And then what we want to do is we want to make this into the identity matrix. So the first thing I'm going to do is divide everything in the first row by 3. Like that. Then if I take the first row and multiply it by 5. So I take this and multiply it by 5, or -5. So this times -5 is negative 1 times -5 is -5. Here you'll get -20/3, and then you'll get -5/3, and you'll get 0. So that's the first row multiplied by -5. Then you add that to the second row, like that. So this becomes 0. -20/3 plus 9/3 is going to be -11/3. -5/3 and 1. Okay, so now my matrix is 1, 4/3, 1/3, 0. The second row becomes 0, -11/3, -5/3, 1. Now I need to get a 1 here, so what I would do is I'd multiply everything by -3/11. So if I do that, I'll get 1, 4/3, 1/3, 0. So 0 times this is 0. -11/3 times -3/11 is 1. Then I multiply this one, so you negative times negative is positive. You'll have 15 third, so you'll have 15 in the numerator divided by 33 in the denominator. 11 times 3 is 33, and this will be a -3/11. So -3/11 times 1 is -3/11. Okay, next I want that to go to 0. So I'll take this row. Let me just write it down. I'm going to multiply that by -4/3. So I get 0, -4/3. And if I multiply this by -4/3, I'll get 4 times 15 is 60, meaning negative sign, and I divide by 99, 33 times 6. And then this one multiplied together, the negative signs cancel out. 4 times 3 is 12. The denominator is 3 times 11, which is 33. So, and then I add these together. No, I don't have those together. So that was the second row multiplied by that. Then I take the first row and I add that together. So you get 1 plus 0 is 1. This goes to 0. Here I have 60, -60/99. This is equivalent to 33/99. So -60 plus 33 is going to be -27. So I get -27/99. Here I just get 12/33. So my final matrix is 1, 0, 0, 1. The first row becomes this, So it's negative 27 over 99. 12 over 13. 33. And then I have 15 over 33 and negative 3 over 11. Now what I could do is I could make everything in terms of 99 as the denominator. So that one's already 99, so it's 27 over 99. To get to 99 here, I'd multiply both by 3, so I'd get 36 over 99. So 3 times 12 is 36. Here I'd have to multiply 3, so I'd get 45 over 99. And here I'd have to multiply by 9, so I get negative 27 over 99. So those are all with 99. So you could then say that the inverse is going to be equal to 1 over 99 times negative 27, 36, negative 45, negative 27. Now I'm going to use my calculator just to check my answer here. So if you can do the same thing. So we'll go back here, and this one will be easy because it's just a 2 by 2 matrix. So you go second matrix, go to edit, choose matrix A. It's a 2 by 2, and the matrix is 3, 4, 5, 3. Okay, then I quit out of there. I go to second matrix, choose matrix A, take the inverse, and then I'm going to, so that's in decimal form. To change it to fractions, I go to math, choose fractions, and I end up with So I end up with 3 11ths, 4 11ths, 5 11ths, and so that's slightly different, but actually there's something here. You can see that this actually, if I divide this by each of these things by 9, so if I take 1 11th here and I divide, so what I'm doing is I'm going to factor out 1 9th, and I'm going to divide everything by 9. You get negative 3, 4, 5, negative 5, and negative 3. So that's the equivalent of I think I must have a sign wrong here somewhere. This must be plus 45. Let's go back. Did I write something down wrong here? Oh, yeah. When I multiplied by 3, I put a negative sign there, so this should be plus 45, plus 5. Okay, so that's what the calculator gave me. So that's good. Now that's not the actual solution yet. What I do for the solution is I take the original right-hand side of the equation, negative 2 and 4, and I multiply that by the inverse matrix, which is going to be 1 11th times negative 3, 4, 5, negative 3. So I get negative 1 11th, and then when I take this times that plus that times, let's see, am I doing this right? This is I think I've got it the wrong way around. I think I got to multiply it the other way. So I'm going to take the inverse and multiply by the negative 2, 4. Okay, so what you get is you'll have 3 times 2 is 6, plus 4 times 4, which is 16. 16 plus 6 is 22. So that's the first one. And then the second entry is 5 times negative 2, which is negative 10, and negative 3 times 4, which is negative 12, so that becomes negative 22, which ultimately, if you divide both by 11, you get 2, negative 2. So what that's saying is that from the original equation, that x equals 2 and y equals negative 2. And I think that's right. Because let's write out the original equation. Okay, so if I plug in x equals 2 and y equals negative 2, I'll get negative 2, which checks that one. And if I take x is equal to 2 and y is equal to negative 2, that's 10 minus 6, which is 4, which is good. So it does work. So let's kind of review what we did there, because it did get kind of complicated. We took the original coefficient matrix associated with the x and y variables. We created an augmented matrix. We did the matrix multiplication and other stuff, not matrix, but just row operations, to change this to the row using Gaussian Jordan elimination. I came out with this being the inverse matrix. I simplified it down. It turned out it was 1/11 times this. And the solution to the equation, you take A inverse times the right-hand side of the equation, of the original equation. When you multiply that together, you get a matrix 2 comma negative 2. X is 2, y equals negative 2. That's how these work. Okay. And we have 59, which is a 3 by 3. We're going to be in a 3 by 3 matrix. So this will be fun. I'm not sure if I like your idea of fun. Now the reality is that in the long run you wouldn't do this by hand, but it's good to know, there's certain things you have to do the hard way first, and then once you have passed the test, then you can use the automated versions. But okay, so the way we would represent this system of linear equations is in the following matrix form. So that's my coefficient matrix. This is my variable matrix. This is my constant matrix. Like that. So the whole idea is I'm going to take the inverse of that, and I'm going to multiply by the inverse of that. The end of this inverse of that times that, that'll give me the solution. So I could use my calculator, but I'm not going to wimp out here. So I got to create this augmented matrix with the identity matrix. Okay, let's see what I want to do here. I don't think there's anything that... So the first thing you might be able to do is to switch rows. So I'm going to just switch the first and second row. Okay, then I'm going to take the first row and divide by 2. So I'll get 1, 1, 3 halves, 0, 1 half, 0. Okay, so that's first step. I've got 1 here and 1 there, so that's a little nicer than not doing anything. Okay, so the second thing I'm going to do is I'm going to take the first row and multiply by -4. So take these. Multiply by -4. So that'll give me -4, -4, -6, 0, -2, 0. So -4, you get -12 over 2, which is -6. Here you'd have -4 over 2, which is -2. Okay, so that's the first row. Then I add that to the second row. And the result is 0, -5, -5, 1, -2, 0. Okay, so that's going to go here. So you get 0, -5. Now, actually, what I'm going to do one more thing. I'm going to divide everything by -1. So this will become 1, 1, -1/5, 2/5, and 0. So I divided by -5. Okay, so now I'm going to put that in there. So that's 0, 1, 1, -1/5, 2/5, 0. Okay, now I'm going to take the first row again and we'll multiply by -5. So I take these and I multiply by -5. So I'll get -5, -5, -15 halves, 0, -5 halves, 0. So that's just that. Then I'm going to add that to the third row. So I'm going to 5, -2, 6, 0, 0, 1. Add those together. I get 0, -7. Okay, so we've got -15 halves plus 12 halves, so that's -3 halves. 0, -5 halves, 1. Okay, so I'll put that in there. So you get 0, -7, -3 halves, 0, -5 halves, 1. Okay. Okay, now what I'm going to do is I'm going to take the second row I'm going to multiply that by -7. So I'll get 0, -7, -7, 7/5, -14/5, 0. So, and then I'm going to add that to the third row, which is 0. Actually, you don't need to multiply by -7, just need to multiply 7. Let's change the signs here. So this would be negative there. Okay, now I'm going to add it to the third row. -7, -3 halves, 0, -5 halves, 1. Add those together. I'll get 0, 0. 7 minus 3 halves. So this is 14 halves minus 3 halves is going to be 11 halves. Here we have -7/5. We have 14 halves minus 5. 14/5 minus 5 halves. So this will be 28 tenths, and this will be 25 tenths. So we subtract those, we add those together. So 28 minus 25 is 3 tenths and 1. And then, so that'll be our new third row. What we'll do is I want to get 1 here. So we'll multiply everything by 2 11ths. So you get 0, 0, 1. 2 11ths, you'll get negative 14 over 55. You'll get 6 over 110. And you'll get 2 over 11. Okay, so let's write out where we are. Obviously, there's a big chance of making mistakes here. That's why the computer is so nice, because it's not going to make a mistake as long as you enter the data correctly. Okay. Let's make my head hurt. So what we do now is we would add these, we would subtract this from that. Okay, so let's write this down here. So what I'm going to do is I'm going to take the second row. So I'm going to give this a try, and if I don't get it right the first time, I'm going to go back to using the computer. Okay, so I'm going to change the signs here. Okay, so we add those two together. So you get 0, 1, 0. So this is, in terms of 55ths, this is a negative 11 over 55. So you add, so there you'll end up with negative 11 plus 14, so it's 3 over 55. Here, to get it to 110, I need to multiply by 22, I think. Yeah, 22. So this is, so multiply by 22, so you get 22 times 2, which is 44 over 110. Let's check that out. 44 divided by 110 should be 0.4, which it is. Okay. So then you got 44 minus 6. So that becomes 44 minus 6 is 38 over 110. And then you've got negative 2 11ths. So that's the new second row. So I can go ahead and write those in there and keep the last row the same. Okay, the second row is 1, 0, 0, 1, 0, 3 over 55, 38 over 110, negative 2 11ths. Okay. Now what I'm going to do is I have to do two things. I'm going to take the first row, and I'm going to take the negative of this one. So I get 0, negative 1, 0, negative 3 over 55, minus 38 over 110, plus 2 over 11. So that's the second row with the sign changed. So there you get 1, 0, 3 halves, negative 3 55ths, and here we have half, which is 55. 55 minus 38 is 17, so I get 17 over 110. Here I have 0, so that's just 2 11ths. So that's my new first row. But then what I do is I take the last row and I multiply the last row by negative 3 halves. So I get negative 3/2 times that. So then you get negative 14 over 55 times negative 3/2, which is going to be 3 times 4, that's going to be 42. 42 over 110. So it's 42 110ths. The second thing I have this times, so I have 6 over 110 times negative 3/2, which is going to be equal to, well, 6 divided by 2 is 3, so 3 times 3 is, so you get negative 9 over 110. Negative 9 over 110. And then the last one is 2/11 times negative 3/2, which is going to be negative 3/11. So that becomes negative 3/11. So I add those together, and I get 0, 1, 0. So I've got 42 110ths. So this is 55 55ths, so that's 6 110ths. So 42 minus 6 is 36 over 110. Here I've got 110ths, so 17 minus 9 is 8. 8 110ths. And then I've got 2 minus 3, so that's minus 1 11th. So I can put that up here. 1, 0, 0, 36 over 110, 8 over 110, negative 1 11th. And what I could do is change them all to 110ths. So what I'm going to do is factor out 110. So you've got 36, 8, minus 10, multiply by 10 to get 110ths. 6, 600tenths, 38, negative 20, minus 28, 6, 20. So that's my inverse matrix, and we're just going to check it using the calculator because it's so much easier. And I can see whether I've made a mistake at this point. So second matrix, edit. Matrix 1 is a 3 by 3. Put my numbers in: 4, 1, 4, negative 1, 1, 2, 2, 3, 5, negative 2, 6. Quit. Second matrix, choose A, do the inverse of it, change that to a fraction, and I get, here's the answer. Let's see if I made any mistakes or not. Pretty close. Okay, so actually they were able to simplify down to 55ths. So if we divide everything by 2 inside here, which is possible because they are all even. Okay, I think I won. I think I've done it. I'm very proud of myself. Yep. Okay, so that's the inverse. Now, what we need to do is take that and multiply by that. So let's just keep it on this page. So the inverse was 1 over 55 times see what the numbers were. Okay, something's wrong here. Okay, so we ended up with 18, 4, 3, 19, negative 14, 3, negative 5, negative 10, positive 10. Multiply that by negative 5, 10, 1. So I get 1/55 times. Okay, this is going to be just a 3 by 1. So we're just going to take 18 times negative 5 plus 4 times 10 plus negative 5 times 1. And I get negative 55. Okay, then I'm going to take this row, multiply by that column. So you're going to have negative 15 plus 190 minus 10, 165. And then you take negative 14 times 5 plus 3 times 10 plus 10 times 1. You get 110. And you can see each of those are divisible by 55. So you would get negative 1, 3, 2. So what that's saying is that x1 equals negative 1, x2 equals 3, x3 equals 2. And we can actually do that on our calculator. We've already got the A matrix okay. So we go to edit. We're going to do B matrix is going to be a 3 by 1. And the B matrix was up here, these coefficients, which were negative 5, 10, 1. And we quit. Then we go to second matrix, choose matrix A, do the inverse of it. Go to second matrix, choose matrix B, push enter, and you get negative 1, 3, and 2. Okay, so the calculator is my friend. And that's it for that. Okay, we're done.